The theme of the presentation is Lesson Learned in Use the Clash Matrix, effective tool for checking the quality assurance of BIM model. The presentation will address the use of the Clash Matrix tool for the quality assurance process of engineering model in BIM. I will share with you my experience with the use of the Clash Matrix tool in Brazil. I have used the tool in several airport engineering projects, in which I have worked as a BIM coordinator. I am an architect, safety engineer, and master in civil engineering from the Federal University of Espírito Santo, Brazil. I am also an architect, BIM manager, and BIM coordinator at the Brazilian Airport Infrastructure Company Infraero. I am professor and coordinator in postgraduate course involving the use of BIM. I am certified as an airport safety professional. I am PhD student in environment engineering at the Federal University of Espírito Santo. To guarantee the quality of BIM model in engineering projects, it's important that procedures are foreseen before the start of project execution, so that the expected benefits for the construction of building of infrastructure work using the BIM methodology are materialized. One of the best practices is the use of clash matrices. For this, it's possible to standardize an analysis, enable comparison mechanism, evaluating process performance, and increasing the potential for decision making. To obtain effective actions in relation to the quality assurance process of BIM models, it is important to structure method so that the BIM models to be developed include appropriate engineering solutions and comply with the BIM execution plan in terms of their graphic and non-graphic information. The presentation will present the experience gained in use the clash matrix for engineering projects. The presentation will be structured as follows. What is called quality assurance of BIM models? How to design and execute a clash matrix, and lessons learned on how to use the matrix in the context of project under development. Quality assurance verifications consist of a method of verifying the accuracy of the information contained in a BIM model. To establish the accuracy of the information, it must be compared with some reference information. Therefore, strategies must be designed and implemented so that the BIM model to be developed are in accordance with the pre-established rules regarding graphic and non-graphic properties. Regarding geometric inconsistency, some items can be mentioned, such as compliance with the project-based points, conflict between geometric components, duplicity between BIM objects, failure to meet the specified level of details, components located at incorrect levels, among others. Regarding information consistency, we can mention inadequate information related to the georeference of the model, object with naughty and generic IFC classes, failure to comply with the information classification system, failure to meet the specified information level, among others. Of all the inconsistencies mentioned, those verified Through practical experience, the most difficult to control due to their high accuracy and the assumptions that need to establish are conflicts between geometry's components. In this context, this development of clash matrices emerged a fundamental tool. How to design and execute a clash matrix. A clash matrix is a table with a crosses between disciplines where you can, for it, obtain a sequence of execution of interference detections. Firstly, a hierarchy of flexibility between disciplines is defined that those disciplines positioned at the base of the pyramids have less potential for flexibility, and those positioned closer to the top have creative potential. Initially, the first step is to design the priority to flexibility between project disciplines. Below is example for building projects. According to figure, we can identify the following situation. We have at the base of pyramids the disciplines that present the least possibility of flexibility and moving towards the peak of the pyramids. The potential for flexibility is reduced. For example, if there are conflicts between the disciplines of architecture, structure, and mechanical system, the discipline that must be modified is mechanical system, depending, among others, on the costs and efforts required to change this discipline. However, if there is a conflict between mechanical system and hydrosanitary system, the hydrosanitary systems must be more flexible. Mechanical systems usually have components with larger dimension, which present greater space restriction and provide great impact when changing them. If there is interference between sanitary system and electrical system, the electrical system must be changed due to the fact that in most cases they have smaller dimension. For building projects, the matrices may behave as follows. The project disciplines are in the column and lines on the left. In the first analysis, there is architecture and structure, column 2. The second analysis, column 3, architecture, structure, and mechanical system, as follows. Thus, a technological model verification tool, for example, Navisworks softwares, can be used to carry out test 1, architecture and mechanical system, and test 2, structure and mechanical system. However, specified analysis can also be carried out between disciplines. For example, breaking down column 3 and shown below. The number in red refers to the disciplines on the right of the table and that the analysis will be carried out with all the elements and sub-elements on the left. How to use the matrices in the concept of project under development. Once you know what a clash matrix is and how to execute it, it's important to recognize that it is also necessary to design method and process to enable the appropriate use of this tool and contract to be executed. The tool must be designed and executed by the person duly assigned in the BIM execution plan. Firstly, it is important to define milestones for receiving the models. The models will be sent by the discipline leaders and received by the BIM coordinator. The BIM coordinator will be responsible for receiving the models, carrying out a series of geometric and ethnographic information checks on the models, and leading the BIM coordinator meetings in order to discuss the result for appropriate classification and approval. In the following example, you can see a model in XLS format of one of the works involving the use of clash matrix that I carry out as a BIM coordinator. Other example, the BIM coordinator must have a personalized and standardized checklist regarding the inconsistent to be investigated. He will adopt the clash matrix that he designed in BIM execution plan will carry out the interference using a technological model checking tool and issue interference reports. During the meeting, he must talk to the professionals regarding the interference present. It is also important that rules are defined in relation to approval of interference funds. An example for checklist. The question that should be asked is, will the slab be built in one piece and then will a hole be dry? Another situation, show an evaporator installation in the large mechanical system crossing a slab be considered as interference? The question is, do the dimension of this element represent a significant reduction in the estimated concrete for the slab that need to be quantified? Therefore, it is likely that it will, it will be necessary to drill a hole in the models beforehand, even because the structural element will possibly have to provide for the design gaps. All of these questions must be standardized and pre-defined. Situation 1. Subject A and Subject B. Interference found. Slab and air conditioning ducts. Solution: drilling in the model. Motivation: the hole in the slab must be forcing in advancing in the project, thus reducing the amount of concrete structural force in the spreadsheet. Situation 2. Subject A and Subject B. Interference found. Slab and sewage system piping. Solution: maintain the interference. Motivation: small pipes will not significantly compromise the number of structure. Other examples. In the following example, it is possible to visualize the execution of the strategy for quality assurance of BIM model in a project for Brazilian airport in which I worked as BIM coordinator. Below is the article I have recently published on the official BIM Coordinator page. You can access it using the QR codes. Regarding the conclusion, I would like to highlight proper integrated use in clash matrix project can enhance gains when adopting BIM model for the very possible use in a project's life cycle. The experience absorbed in airport projects carried out by Infraero has demonstrated interesting results that can be applied in other sectors. Airports have great potential to replicate results as they cover the most diverse building and infrastructure demands and information exchange needs. This concludes the presentation. I would like to thank everyone who is watching, and I would also like to leave a quote from Martin Fisher. Knowledge is the process of accumulating data. Wisdom lies in its simplification. Thank you very much to everyone, and see you next time.